Hi, my name is Behruz Amirzadeh, and I'll be presenting SimpleOS for my final project for the CSCI-E92 operating systems class. So to give a brief overview, this operating system runs on the NXP Kinetis K70 platform, which has a 32-bit ARM Cortex-M4 processor. The OS has a flat in-memory file system, and it also has a device-independent I/O architecture for different I/O devices that are on the platform, like LEDs, push buttons, the UART, and so forth. And it also supports multi-programming and uses the SysTick timer to schedule processes. It tracks the system time with the flex timer. And to be able to demonstrate some of the multi-programming features a little bit better, it also supports a dual window shell interface. And for its special features, it supports pipes, it supports Unix style signals, and it also has support for user identities and login and file permissions. So initially, when the OS starts up, it initializes the master clock generator and then sets up the SDRAM for general purpose memory usage and the LCD buffer. And then it initializes all other devices on the platform and starts the SysTick timer. And it then creates some default users, such as the root user, and it creates the in-memory file system and the device files associated with the devices in the platform. And finally, it enters the unprivileged mode and spawns the first shell and asks for the user to log in. Now, to dive a bit deeper into how the special features are implemented, we start with pipes. The pipes are implemented as a FIFO queue with fixed size arrays. They have a somewhat similar behavior to Unix pipes in the sense that the reader is blocked when the pipe is empty, the writer is blocked when the pipe is full, and also the reader receives end of transmission when the other end of the pipe is closed. The pipes are created on the fly when the shell commands are spawned and the pipe character is detected on the command line. And this allows the operating system to support multiple pipes between basically multiple commands. And finally, pipes are destroyed when the processes at both ends of the pipe are killed. The other special feature are Unix-style signals, in which a signal handling function is tied to a signal number. The signal handler runs on a separate stack from the process, and it's the responsibility of the scheduler to switch which stack in the process is active. And to be able to implement this, there are some extra fields in the PCB. There's the signal stack pointer, there's the array of signal handling functions, and also the arguments to the signal handler, and also the signal handler execution state. At any one time, the signal can be active, inactive, pending, or finished. There's also a SIG action system call, which the users can use to define handling functions for the signals. And only a single handler can be run at any one time. The final special feature is the user identities and permissions. The OS supports Unix-style 9-bit permission model. And there are some user management functions for adding, deleting users, and switching users, and setting the password for users. There's also file permission management utilities like chmod and chown. The switch user command spawns a new shell for the target user. And the passwords are stored in their hashed form using a SDBM hash function. And also group management and creation is not supported.
So I can now run the OS. So initially it shows a login screen, which I can use to log in as root. It shows two windows, and by default it spawns a shell in the bottom window. There are actually two shells running right now, and I can switch between the windows by using the SW command. And this the multi-window feature is done by VT100 escape sequences. For user management, you can use the add user command to add a user, for example. Give it a password. switch this user. Now here we can see it spawned the shell for the admin user as well. You can list the files with ls, create a test file. You see the file is created with the same user as the user of the running shell. You see the permissions of the test file is read and write only for the admin users. So now if I switch to the other shell, try to access this file. First I will switch to guest user, which already exists. If I try to open the test file for reading and writing, if I try to write to this file, if I try to write to this file, I get permission denied. And if I switch back to that other shell, I can do chmod 777 on test. Now this file has permission for everybody. Let's switch to the other window again. Try to write to that file again, and this time it successfully wrote that byte to that file. There's also support for pipes. We have the output of PS to WC, which gives us the number of characters in the output. And also have LSOF. We can, for example, pipe it to get the first 7 lines. You can also do multiple pipes. You can pipe the output to the LCD. There's also support for signals. For example, I can spawn a new shell here. Then trap signal 1 and have it run, for example, ls. And if I switch to the other shell, send signal 1 to that process 3 which we just spawned, it will run ls. Thank you.